Hello out there. Good morning. This is the CNC dude Ed Doherty from Suncoast Technical College, and I'm going to talk about a stumbling block I see a lot of students have. Oh, by the way, I love this shirt. It's a Mastercam shirt. I know Fusion up here, but I always love the shirt that says "Eat, Sleep, Machine." That's what we do. All right. You notice I have a vise here. This is the Kurt 6-inch vise, right? And I have another one next to it, two vices. And on top of that, I'm going to throw in a part. I'm going to just shut this vise off, move up a little bit, and I'm going to shut the vise off. So normally when we're learning all this stuff, first we're drawing this thing, or we're going to make it, and then we got to figure out how to make it and how to hold it. We're giving a lot of information, but at some point we have to think about it. How are we going to coordinate the CNC machine to this part? And it actually goes back to the old manual machining days of how do we create our coordinates. So let's get our blueprint out. Okay, back to the blueprint. This is a 3-page blueprint. So we really need to look at the last page right here. This has most of the coordinates on it. Our 0, is up in the upper left corner and also the top. So when you draw this part, it's coordinated to we call it the origin. So drawing it and running it kind of goes hand in hand, right? We're trying to create this thing. And we need at least 2 operations because we have to hold on to this thing and machine as much as we can and then start to finish machining. All right. So we got the drawing and the coordinates. Let's go back to Fusion for a sample here. So I'm going to go into design, right? And I have the origin turned off. Now I have it turned on. So this is where we were drawing from, our coordinates. I'm going to relate this to what we call the WCS, so the work coordinate system. CNC machines need to know where the part is in order to figure out how to machine this thing. You have to set that up. It doesn't know where it is. So I'm going to turn on material. This is material. This is like raw material right here. I made it kind of see through, see the part inside there a little bit. So buried inside this is our part. And notice where the coordinate is for the part. It's not lined up with the material. So you got to figure out, where do you want to put that? So if I go to manufacture, and I'll go to setup 1, right? Setup 1. Edit the setup. All right, you have a selection here, right here. Where do I want to put it, right? And you got the origin right here, from origin, right? Origin. You got these selections. Model origin, selected point, model box point, or stock box point. All right, if we're following the Titan videos, let me draw up a setup sheet here. A setup sheet right here. It says in the instructions, and this would be something you would have to do on the job. I'm thinking about when you're going to work and you need to follow instructions. These are written instructions. Even says right down here, these are the original ones. Use parallels inside of hard drives. Material is 1 inch high. Hold about 200 thousandths in the hard drives. Make sure you have enough stock so you can get around it without hitting the hard drives. And this is critical information over here. X-axis is left edge. Move in 50 thousandths from rough stock and re-zero. So we're doing 3 shifts. We got a positive 50, a negative 25, and a negative 20. What does that really mean, right? Cancel. All right. This is your part. There's your stock, right? So if you're using this coordinate for your setup, edit here. You're doing model box point, just like in the video. And you go to set up your part. Now, if you're using an edge finder or a probe, and this is the top view, you're going to be going, actually, I'll draw something. Design the surface. I'm just going to draw a circle. 0.5. That's an edge finder diameter right here. I'm going to move this around. So you move this around. You got your edge finder and you go, and right there, and it kicks off. Or the probe, right? The probe is going to find this coordinate and report it back to the CNC machine. It's going to be this coordinate, not this coordinate. So if you don't follow the instructions, when you go to machine the part, you'll have no cut on this side and no cut on this side. Because you didn't shift it, you didn't follow the instructions. So that just pertains to the Titan projects. And the same thing would be the Y coordinate, and the same thing would be the top coordinate. Your part is inside, right? Inside. Okay, pop. Let's take away the, I should rename this. I like to shorthand everything. Stock. M. I know what everything is. Shut the stock off, right? Boom. Right there. See, right there, you'd lose the, you would have no cut on this side, no cut on that side. So if you're literally following the instructions at the machine, you need to shift the coordinate. And that would be on a Haas machine or on a Fanuc machine, like a Doosan. You would get the coordinate, like the probe would report the number automatically. And if you're all using G54, we got X, Y, and Z. Then you have to go in the machine and shift those coordinates. And I believe Titan has some videos on that, how to adjust coordinates. Now, on both machines, they have how to adjust coordinates. Fanuc's got, I think, input and input plus, and a Haas uses the lower right button as the enter button, which is also the calculator button. And the upper left one, the F1, is for setting in a hard number. So they can both do add and subtract. And that's what you want to do. You just want to shift by using add and subtract in order to get it to line up with the setup sheet, because the setup sheet is the directions for the machinist. And you really got to think of this as three different jobs. You got your programmer, you got your setup man, and you got your machine operator, right? As setup man, you may be getting programs from somebody else, so you need to follow the directions. So if you're not coordinating, there's going to be there's going to be some confusion. So now, getting back to the setup, I'll go back to the setup, right? You just go back to setup, hit edit. And I could also do this in Mastercam to show you. If I picked stock box point, right, hit OK. Notice that the coordinate origin of the part and the coordinate origin of the stock are two different locations. This would actually be a simpler setup because you wouldn't need to do the shifts. That's like step one. But if we're trying to teach you to follow directions, and if you go in and you do these shifts, then you're shifted, and you're going to have a problem with the other two sides or the third side. So you got to kind of decide which coordinate you want to use. Now we have some other selections here. So let me just zoom up. we got like conflicting origins now. You got the WCS origin, and you got the you got the part origin, and you got the work coordinate system origin, like where the machine thinks 0 is. Either one of these will work as long as you follow the instructions. If you decide to do stock box point for this part, then you cannot do the shifts. Ignore that. But that's going to be a culture in whatever shop you're in, whatever way to decide to do it, in order to coordinate that. All right. Let's go to operation 2, and let's go back out. I'm going to turn on vice. Here's a vice. Vice is here. Let's see, is it on? How come it's not on? Oh, probably because I didn't put it in the setup info. Fixture. Select vice. There it is. Okay. Now it appears. This can be very helpful, especially for teaching. So we got the origin. I'm going to shut off the origin of the part. I'm going to just talk about work coordinate system, because now you really don't care. You want to get this thing machined. So if you use this coordinate and you got to put your part in, like we use these things called step jaws, which are like built-in parallels. We already made them 200 deep. And we load the part in. So if I, let me go back to, I'd have to move both. I'm not going to do that right now, but you get the idea. We got to clamp it there. We're going to have a work stop on this side to control where we load them. And we have to think of this as production, like we're going to make 100 of these. So how can we hand it over to the operator so they can load these and come up with 100 perfect parts? All right, so you decide to use stock box point as setup guy, because the programmer said, my setup sheet says stock corner upper left top. That's the coordinates to use. So you do upper left top, edge finder, and then maybe set the tools off the top of the part, right? Or you do probe, all 3 coordinates. Then you're pretty good to go. You're going to run your program, right? We're going to run the program and then complete operation 1. Now we got to go to operation 2, right? Turn on, we got to flip it over like this. And in reality, let's turn on the origin again. The origin is really down here. And it's really critical to be aligned to the model. So at this point, you cannot use the stock box point for setup. You can't even use stock for your finding your coordinate. So in this case, some people use the bottom like this. We flip the part over. Right? Let's flip the part over. This, we made it from this side, right? Here's our part origin, right? And we want to, according to the blueprint, the inspection people are going to use this upper left corner and the top to inspect the whole part. So if you had like even chamfer or any holes on the other side, it has to line up to everything. So you cannot be accurate by using the material as your setup. You got to use the model. Right? And some people call this the hat. You have like extra material on top. And if you had a probe system, here's my old edge finder right here. Edge finder. And if I move the edge finder up to here, I can't get to there. This is the material. Can't get to there. Right. If I had a finished part, I could just substitute that and edge find this side, edge find this side, and set my tools to the top. Or I could do probe this side, and probe the top of the finished material. If I probe this and the raw material or edge find it, I'm not coordinated at all. So, and also I can't be accurate enough. Like if you had a model box point on this side, which you got to be model box point for your setup. This side can't be stock. You pick stock. Go to stock box point, and you pick that corner there or whatever. Oops, fix that. Okay. And you pick that coordinate. Remember, this is raw material that was cut on a saw. This is just bar stock. It is not machined. It just came out of a factory. So you're not accurate. So even if you pick these coordinates and you decide to go edge find this side, edge find that side, and your part is coordinated to this, and you decide to set your tools at the top, you'll be kind of close, but not accurate. We want to be accurate within, well, actually within 1,000, but we'll say 5,000. You're not gonna get there. You got to be aligned to the part, the model. Think of the model. So you cannot be accurate without going to the model. Right there. Right there. I decided to use the upper corner than the lower corner. Why? It's a common technique in most shops to do it that way. They're using the XY of the real part, and they know where the top should be after this is all removed. I have rarely, but I've seen people use the lower corner, but it's actually a matter of how you're going to set that up. And also the communication. So if you get your setup sheet, let me get another setup sheet. All right, so this is Titan setup sheet. It says Operation 2. All right. And I kind of converted this to use Tool 1 from Operation 1 and leave, and don't change this to Tool 2. Leave it on Tool 3 because we're gonna reuse the tool from Operation 1. So, and Titan kind of used a system to like do the project in one vise, so which would make it simpler. But I just made some. Oops, what's going on here? So down here, I crossed out X0 is upper left. Flip part 180 degrees left to right. Z0 is top of finished part, 750 above parallels. So we're doing Z0 the same. Where is the top of the model? And they're going to sink the part a little deeper. We're using a 2 vise method, which is kind of common in the industry. So if you had one side is Operation 1 and you move that to Operation 2 so you can be more productive. That's just the way I've been teaching it. But Titan's way is like a 1 vise method. And if you're a beginner and that's all you have, this works just fine. As long as you follow the procedure. X0 is upper left. And we just decided to use upper right as flipped over. So this one is X0 is right side of finished part, no shift. Fixed jaw side, no shift. And top of part, 750 from parallels, just like he did here. You can do it a couple different ways. You cannot use your half-finished part to do this. I used to use something called a 1, 2, 3 block. I put the 1, 2, 3 block as a replacement. And I probably should put that in my design here. All right, back to Fusion. So I take this out. Let me turn the vise on. Vise is... Oh, on wrong side. Hold on. Okay, I'm literally going to make a copy and move this. This is really what's going to happen. I'm going to move it over here. And let's see, flip it upside down. Move it over here. Move this down here. Deeper. A little bit too deep. What is gotta do 1 point. Okay, that's pretty good, right? Right. I'm gonna put some parallels underneath. I'm gonna squeeze it there. I'm gonna put a stop on this side. Zoom this. So this is the second side, right? Over here. So I'll tighten this up, put a stop on this side, but I don't have a finished part at this point. But I'm going to use this upper corner for my work coordinate system. So if I had a finished part or a 1, 2, 3 block, I'll put the 1, 2, 3 block in and edge finder probe this side, edge finder probe that side, and probe this side. I'm probably going to make a part 2 of this and substitute the 1, 2, 3 block. But that's what I'd be doing. I could take a finished part, set this up, and I'm trying to match this. Think of it that way. I'm trying to match this. But if I have a half-finished part, I don't really have a hard time doing that. So if I substitute something that's a perfect rectangle, I'll say that, and I probe edge find the right side, probe edge find the back, that aligns me to my original. The only thing that is left to do is machine the top, which has material on it. The material from this side. And how do I do that? Okay, let's see where I left off. Now we're over here. We got this extra material on. We're putting the part in a little bit deeper. I didn't have time to put the parallels in. But how do I get to that coordinate? Now, Titan was using the upper left. Edit. Model box points still, right? There's all your box points, upper left. Notice X point to the right, Z up. I'm just trying to stay true to the original origin, a little more industry standard. And also on this vise, we have the work stop on the right side. Okay, back to my lesson. Here's our XYZ coordinate, right? Good grip on the part. Nice precision jaws against precision part. Want to make sure it's clean. We don't put any dents in this thing at this point. We got a parallel, precision parallel underneath. So we're trying to make a precision surface on the top, not a raw material. And how do we coordinate that? That's the catch, right? So remove this part, or so you either have a finished part or substitute a 1, 2, 3 block. Then you probe this side. Oops. And you probe this side. And I choose to use the top of the block, which is about the height of the raw material. Then I shift it from 1 inch, which would be 1 inch total. Actually, I need to have a 1, 2, 3. And here, let me go get one. Aha, I found one. 1, 2, 3 block. Let me pull this up here. Every shop has one. Titan's got videos on them. 1, 2, 3 block right there. And what's the rest of it? Projection cube. We don't need the projection. All right. Okay, let's go back here. I'm going to bring this in. Nice to having a virtual machine shop. All right. Ooh, I brought the cube in with me. Now this is called a component. When you please shut off the. All right, I got to move this where I want it. Okay, I'm going to put it over here. I'm going to shut off my 1M operation 2. I'm going to shut off that side. Shut off the left vise. So I just want to look at this side. All right, I'm gonna rotate this. Let's see, this way. That. It. Let me turn the 1M on. I didn't capture the. I'm close. All right, I want to align this. I'm gonna do a line. Oh, let's cut off the block from it. What do we want to do? I want to align this. Hard drive. Put parallels in. Remember 1, 2, 3 block. I want to replace line this surface, that surface, this surface, that surface. Surface. Oop. There we go. So I'm substituting the 1, 2, 3 block. Take the part away. Capture position. Okay. So that's my setup. Got the part that I want to make and the setup, right? I'm going to probe this side, this side, this side, right? My part is lower. So if I inspect from this surface to that surface, inspect, measure this, that. That says it's 250 thousandths difference. So I need to shift it from here to align to my model box point. Then I take this out, put in my part that's partially done, right, like that. And on my setup, I did setup as model box point upper corner, and in the end, I'll have everything aligned to this. The stock I'm using, I got to use a newer method called preceding set. Oh, older method I use. All right. I even put a thing called a manual comment in here. Stop. That was for a 2 operation. Base mill. I got my feeds and speeds. Got stock and knows where the stock is. But we cannot use model box point on this operation. We got to be able to identify the extra material. So we're going to use stock top. I'm going to just reset these to the defaults. What's system default? That'll work. Top height is identified as stock top, and bottom height is the finish line is 0. Then we're going to use multiple depths. And same thing, system default is 40 thousandths. And both directions. Okay. All right. Going to do multiple cuts to work its way down to the model top. If you don't have stock top, let me try this without all model. Notice there's only one cut, even though I have multiple on, because it doesn't know it's there. Gotta switch it up. Top, stock top, and stock top, but leave model top is bottom, multiple cuts. Then I take my chamfering tool from operation 1, select the chain. I'm going to actually, like if I have a model, I pick this one. Heights. Now I can go back to model topic. And I use, if I have a model chamfer, I use, if I don't, I move this to 10,000ths. That's it. Done. We'll go back to our setup sheet here. And this is a Fusion setup sheet. And we're using WCS number 2, which will output G55. So you have 2 different coordinates. And I also make it a different program number so you don't keep on overwriting the first one in case you have to go back and make it the first one again. And we're using model box point for the corner. We're using tool 1 and 3 from operation 1. That's it. And that'll get you how to get to your zeros. Oh, I get 31 minutes on here. I want to also cover the other parts because where do you put your WCS? But remember, you must be aligned to the model. So that's a must. Okay. CNC Dude signing off. Talk to you later.